Hey friends, welcome back to ETC Information English channel. Today we are going to discuss about ISRO Chandrayaan-3 mission. Chandrayaan-3 is the follow-up mission to Chandrayaan-2, which aims to perform a safe landing on the lunar surface and the rover's capabilities. Lander and Rover are included in the configuration. It is launched by LVM-3 SDSC Shar Sriharikota. The spacecraft has achieved 51,400 km by 228 km square as per plan. The Chandrayaan is expected to land near South Pole on 23rd August. This vehicle is divided into a lander module, propulsion module and rover. Let's talk on lander module. Lander payload has Chandra's surface thermophysical experiment to measure thermal conductivity and temperature in the lander payloads. Lunar seismic activity ILSA to measure seismicity around the landing site. Langmuir probe LP to estimate plasma density or its variations. A NASA passive laser retroreflector arrays has been adjusted for lunar laser ranging studies. Let's talk on rover payload. It consists of alpha particle X-ray spectrometer APXS and laser-induced breakdown spectroscopy LIBS to obtain elemental composition around the landing site. Chandrayaan-3 comprises lander module LM, propulsion module PM, and a rover aimed at developing and demonstrating new technologies required for interplanetary mission. The lander will have the capability to perform a soft landing on the specified lunar site and deploy a rover that will perform chemical analysis of the lunar surface during its mobility. The lander and rover have scientific payloads to conduct experiments on the lunar surface. The main function of the propulsion module is to move the LM from launch vehicle injection to the final lunar 100 km circular polar orbit and to separate the LM from propulsion module. In addition, the propulsion module also houses a scientific payload which will be operated after the separation of the lander module. The launcher identified for Chandrayaan-3 is GSLV Mk3, which will place the integrated module in an elliptical parking orbit EPO of size 170 by 3600-500 km. The mission objective of Chandrayaan-3 are performing a safe and soft landing on the lunar surface, demonstrate the rover moving on the moon, and the scientific experiment in place. To achieve the mission objective, there are several advanced technologies in the lander such as altimeter, laser and RF based altimeters, laser Doppler velocimeter and lander horizontal velocity camera, inertia measurement, laser gyro based inertial referencing and accelerometer package. Propulsion system has 800 throttleable liquid engines, 58 attitude thrusters and throttleable engine control electronics. It also has navigation, guidance and control, power descent trajectory design and associated software elements. It also has hazard detection avoidance, landing leg mechanism. In order to demonstrate the above advanced technologies in Earth condition, many tests have been done and they have been completed successfully. Integrated cold test, integrated sensors and navigation performance test has been demonstrated using helicopter. Integrated hot test, closed loop performance test with sensors and actuators and NGC using tower crane. Lander leg mechanism performance test in these different touchdown conditions have been tested in lunar bed simulation. Let's talk about the mass. The mass of propulsion module is 2148 kg and the mass of lander module is 1752 kg, in which the weight of rover is 26 kg. That means the total mass is 3990 kg. Let's talk about the different payloads and their objectives. In lander payload, they have radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, that is called RAMPA. Its objective is to measure the near surface plasma ions and electrons density. Chandra's surface thermophysical experiment. Its objective is to make measurement of the thermal properties of the lunar surface near polar region. Instrument for lunar seismic activity (ILSA). Its objective is to measure seismicity at the landing site. Laser retro reflector array (LRA). This is passive experiment to understand the dynamic of moon system. Let's talk about rover payload. In this, they have laser-induced breakdown spectroscope (LIBS), whose objective is to do qualitative and quantitative element analysis and derive chemical composition and infer mineralogical composition from it. So that is easy to study the lunar surface. It also have alpha particle X-ray spectrometer (APXS), whose objective is to determine the elemental composition of lunar soil and rocks. Let's talk on propulsion module payload. So it has spectropolarimetry of habitual planet Earth, whose objective is future discoveries of the smaller planets and to study their habitability. So this is some information about Chandrayaan-3. Hope you like this video. Like and share the video and subscribe to our channel. Thank you.